Yellowstone's alert level is currently green, but don't get too comfortable. This supervolcano is still alive, and it could erupt at any time. New data shows the caldera is breathing, with the ground slowly rising and falling as things move deep underground. If Yellowstone actually blew today, it would be a huge disaster. A 10-foot layer of ash would bury everything as far as 1,000 miles away, and over 90,000 people would lose their lives almost instantly. Now, the problem is there's some strange activity going on there lately, like the rare Aquinas geyser erupting all of a sudden. This is the biggest acidic geyser in the world that measures about 60 feet across. Think of it as a hot spring that shoots up acid. It's also scorching hot, with temperatures that can get over 200 degrees Fahrenheit. The Aquinas geyser was really active back in the 70s, and it used to erupt every 40 to 80 minutes. But it stayed quiet for the last 6 years until it erupted again in February 2026. The water shot 30 feet high and the eruption lasted about 3 minutes. It was quite a show, but people were worried. I mean, is this a sign the volcano is finally waking up? Well, probably not. Geysers turn on and off all the time. That's just typical Yellowstone behavior. But Aquinas isn't the only hot spring out there that's been acting a little weird lately. So, Yellowstone was the first national park in America, and it sits right on top of an active supervolcano. That's why there are over 500 active geysers over there. Basically, they're hot springs that get heated up underground and shoot water and steam into the air every so often. These geysers are shaped like a long tube or a hole that goes deep into the ground and fills up with water. Since the water at the very bottom is so close to the magma, or molten rock, it starts to boil. That pressure forces the water up and out in an eruption. Then the water slowly drains back down, and the process starts all over again. Having all these geysers around means the park is basically covered in steam, so it has this really mysterious, misty feel to it. And now it just got even cooler. The ground is literally moving. Lately, everyone's been focused right here, on the Norris Geyser Basin. This spot is home to the Steamboat Geyser, the tallest active geyser in the world. And since 2025, scientists have noted something weird here. The land, which used to be flat, now has a bulge in it. Yep, the ground has pushed up by about an inch along the northern rim of the Yellowstone caldera. But we don't have to worry about Yellowstone finally erupting and destroying the planet. I mean, the situation is pretty scary, sure, but it's not a direct sign that an eruption is on the way. To be fair, this is not even a new phenomenon. Between 1996 and 2004, the land did the exact same thing. The area just south of the Norris Geyser Basin rose by almost 5 inches. This happened because a huge pool of magma, about 9 miles deep, was pushing up from underground. It felt like Yellowstone was ready to erupt at any time. Everyone was terrified, thinking it was the end of the world. But nothing happened. Then, in late 2013, the ground started rising again, at a rate of about 6 inches a year. And that was faster than ever before. Everyone got super nervous all over again. But just like last time, nothing big happened. The event lasted until 2014 and ended with an earthquake with a magnitude 4.9. That was actually the largest one in the area since the 70s, but it didn't trigger a massive eruption. In fact, the last time Yellowstone actually erupted was about 70,000 years ago, and it was not even a huge blast. Now, the area where this happens is known as the Norris Uplift Anomaly, and scientists are getting pretty used to its strange behavior. They say that when magma moves into the Earth's crust, it cools down and releases trapped gases. As that gas escapes, the pressure drops and the ground sinks back down. But just when we thought the area was finally quiet, nah. Back in July 2025, scientists checked the data and confirmed it. The land was rising again. The whole process looked very similar to the one back in the 90s. This might also explain the sudden rise in the number of earthquakes in 2025. I mean, the year was actually pretty quiet overall, with only about 1,100 earthquakes. That's pretty low, considering that at least 1,500 happen in a normal year. But the number of earthquakes suddenly went up at the end of 2025, and most of them happened right near the anomaly. So scientists were pretty sure the two things are connected. According to the estimates, it looked like the ground was going to keep rising for a while. But they also said we don't need to worry about an eruption. The changes we've seen so far are actually pretty small. They're nothing compared to the warning signs we'd get if Yellowstone was really about to blow up. Plus, we have way better tools now than we did in the 90s to track all these ups and downs. But one thing we know about volcanoes is that they are unpredictable. So against all the projections, something strange just happened. The ground stopped rising. Exactly. Recent measurements show the upward movement that had been happening since July 2025 has paused. So, whatever was going on under the Norris Geyser Basin just ceased, for now at least. Then there's something else that shows the caldera is back to normal. In February 2026, there were 74 earthquakes out there, which might sound like a lot, but for Yellowstone, it's not. That's a pretty standard number, because about half of the earthquakes in the park normally happen in swarms. I mean, groups of quakes that hit the same spot around the same time. And these swarms can trigger 10 tiny quakes in an hour, for example. To give you an idea, the year with the most earthquakes was 2017. That year, we were seeing something like 285 earthquakes a month. And even then, that wasn't considered dangerous activity. So, if February only had 74 quakes, we can consider it supernormal. Okay, so the caldera looks like it's quiet again. Does that mean we're safe and Yellowstone won't blow up? Not really. Then again, volcanoes are totally unpredictable. Yes, I'm repeating myself. But even with all the high-tech tools we have today, we don't exactly know how they will behave. So, technically, it can erupt at any time. Now, some people might think that Yellowstone is overdue, but that's not really how it works. If you look at the map, there's an average of about 725,000 years between its big eruptions. Based on the last time it had a big blast, we've technically got another 100,000 years left. But honestly, that average doesn't mean much, because volcanoes don't follow a schedule. Now, if Yellowstone did blow, it would be a total disaster. Some say it would be way more powerful than anything humans have ever seen. Computer models show it would blast tons of ash and toxic gas into the sky, making it almost impossible to breathe. That ash could even reach Europe in 3 to 4 days. The magma would completely wipe out the region, swallowing up forests, rivers, mountains, and anything else in its path. But scientists say the chances of an eruption are super tiny. And there's more. One of the magma chambers under Yellowstone is only about 5 to 15% liquid. The rest is basically solid rock. Hot rock, but still. It's not even clear if there's enough runny magma down there to cause an eruption in the first place. Anyway, that doesn't mean we should completely relax. Experts are still keeping an eye on the North Geyser Basin to see if anything changes in the coming months. Actually, the whole volcano is constantly monitored, and this situation is just another reminder that Yellowstone is still very much alive. It was April 2025 when geologists went back to Yellowstone's Norris Geyser Basin for the first time this year. And while doing their usual check, they realized that something was different this time. Where there used to be just a boring patch of ground, now there was a giant hole, about 13 feet wide, filled with weird, milky, light blue water. Everyone was terrified. Was it the sign that the Yellowstone supervolcano was ready to erupt? If so, it would be a worldwide disaster, the kind that destroys cities. According to the U.S. Geological Survey, if such an eruption occurred, the after effects would be felt all over the world. To start, the areas immediately surrounding Yellowstone would experience pyroclastic flows. That's the lava that erupts out of a volcano, including a high-density mix of volcanic gas, ash, pumice, and hot lava blocks. Those flows would destroy everything they touch, and an eruption of Yellowstone would send them into Wyoming, Idaho, and Montana. Areas further away from Yellowstone would escape the flows, but they would experience falling ash. It would come down heavily in the states closest to the epicenter. The ash would be especially dangerous for anyone breathing it in. The weight of the ash would also pose a serious threat. It would smother crops and collapse buildings as it piles up. Tragic consequences would be countless, but we'll talk about them later, because soon after the discovery, the weird pit surprised even experts. Geologists found rocks scattered everywhere. Some were about a foot across, and all of them were dusted with gray mud. This mud matched the walls of the new spring. It was like the place had simply exploded, but nobody had actually seen it happen. The team checked old satellite images to figure out when it appeared. In December 2024, the ground was totally normal. By January 6, 2025, a little dip had formed. And by February 13th, that water-filled hole was finally there. But the weird thing was that the sensors that usually pick up major hydrothermal explosions didn't detect anything. There was no giant blast or warning signs. Later, it turned out that this puzzling opening in the ground hadn't just popped up in one huge explosion. Instead, it formed from a bunch of smaller bursts over time. Little explosions first threw out rocks, then mud, and eventually created the pit. With time, it filled with silica-rich water. That was a huge relief for everyone. Yellowstone sits on a supervolcano, and its big explosions are a nightmare scenario. Luckily, this time, it was just a slow-building, small-scale explosion. It was dramatic, sure, but totally manageable. You see, Yellowstone National Park is full of geysers, hot springs, and all kinds of natural landscapes. But under the surface, things get incredibly intense, all because of the supervolcano. Now, supervolcanoes are often extremely large. They often have no cone at all, since they're typically the remains of gigantic magma chambers. Once, those chambers flared up, leaving behind a caldera. They're usually located over hot spots. It's no surprise that supervolcanoes can produce super eruptions, and when they do it, they blow more than 240 cubic miles of ash, molten rock, and hot gases up into the air. In other words, 4 super eruptions could fill the Grand Canyon to the brim. Supervolcanoes form when huge volumes of scorching hot magma escape from deep underground. This magma rises close to the surface but can't break through Earth's crust. So, a pressurized pool of bubbling magma gathers at a depth of only several miles. The pressure keeps growing because more and more magma is trying to get to the surface. And then, bang, a super eruption occurs. Now, back in 2015, researchers at the University of Utah mapped out the main magma chamber of the Yellowstone supervolcano and were shocked by its size. And then, they found another one below it. Together, these underground magma pools could hold enough molten rock to fill the Grand Canyon 11 times. All that magma pushes up on the ground above, which is why Yellowstone rises about an inch or two every year. That slow lift might not sound like much, but combine it with the fact that Yellowstone is still an active volcano and has a volcanic explosivity index of 8, and it's enough to make you wonder what could happen if things went south. And yes, Yellowstone has indeed been a bit jumpy in recent years. In March 2023, there were 354 earthquakes in the area. Most were tiny, but the biggest hit a magnitude 3.7, part of a swarm of 106 quakes. Now, before you freak out, experts from the Yellowstone Volcano Observatory say there's no need to panic. No eruption is coming anytime soon. Volcanoes don't stick to a schedule. Just because Yellowstone hasn't erupted in a long time doesn't mean it's about to blow. The park is stable for now. But scientists are keeping a close eye on everything underground, the quakes, the rising ground, and even temperature changes, just to be safe. The superhot plume of magma, a hotspot under Yellowstone, has been churning for 17 million years. The Earth's crust slowly moved over it, making the hotspot leave a trail of volcanoes stretching more than 450 miles along the Snake River Plain. Most of those ancient ones are now buried under layers of lava and sediment. In just the past 2.1 million years, Yellowstone has unleashed 3 cataclysmic eruptions, so massive they managed to reshape the land. Each explosion sent pyroclastic flows, rivers of searing hot rock, ash, and pumice racing outward for miles. The debris piled up in layers hundreds of feet thick, some forming solid lava-like rock. When those eruptions emptied the underground magma chambers, the roof collapsed, forming the massive calderas we see today. Even after those mega eruptions, Yellowstone didn't stop. Between 180,000 and 70,000 years ago, enormous rhyolite lava flows, sometimes over 144 cubic miles, poured out. Some flows followed north-south vent lines. The West Yellowstone flow erupted around 110,000 years ago. The Nez Perez Creek flow followed 160,000 years ago. If you stand at Madison Junction on the caldera's northwest rim, you can see it, a cliff that formed when the Lava Creek Tuff eruption collapsed the land 640,000 years ago. And inside the caldera, you'll see the hardened lava flows snaking across the floor. Figuring out when a supervolcano might blow is like being able to read nature's warning signals. Thousands of years before a massive eruption, the heat underground starts building, and the magma chambers become like ticking pressure cookers. Little signs start showing up. Gas bubbles escape as the pressure shifts, and earthquakes shake the ground. The land above slowly rises. Cracks appear. Hot springs and geysers start acting up, heating even more than usual. Now, what would happen if Yellowstone erupted? Remember those pyroclastic flows we talked about before? They can contain 2 parts: the lower flow of the hot lava that moves at ground level, and a cloud of ash that follows above the lava level. So the 2 of them would devastate huge areas. The ash would even reach Europe within 3 to 4 days of the eruption, but it wouldn't be so bad there. After that, it would only take around 2 to 3 weeks before cooler temperatures set in around the globe, all thanks to the sulfur gas that would get to the upper atmosphere after the eruption. Scientists predict that global temperatures would drop by up to 10 to 12 degrees. These consequences could last for 6 to 10 years, putting an end to monsoons, which could cause widespread famine in Asia. Scared? Well, don't be. The good news is that scientists don't believe that the sleeping giant under Yellowstone National Park will wake up in our lifetime. Experts say the next Yellowstone eruption won't likely happen for hundreds of thousands of years. And even then, it may not be that bad, because scientists have discovered that the magma lurking within Yellowstone is actually split up amongst 4 different chambers. Not only that, but some of the reservoirs of magma are likely to cool down and solidify, lessening the chances of an eruption. So, while an eruption does sound like it would change the landscape of the world, it's very unlikely to happen anytime soon.
It's official. We now know the exact location and timing of the Yellowstone supervolcano's next eruption, and it's called a supervolcano for a reason. It will be thousands of times more powerful than a typical volcanic eruption. When this happens, the planet will face massive disasters. Earthquakes, tons of magma flows, ash and clouds that will block out the sun. The sky will be gray for a long time. We will have a shortage of food because of the lack of sunlight. Planes won't be able to fly. Some species of animals and trees may disappear. One disaster will follow another, like falling dominoes, one by one. Terrible times await Earth, and okay, stop. It's clear we got it. But when will all this happen? Don't worry, you won't be left without an answer. When ordinary volcanoes erupt, it's always a disaster, but only for those places that are located near the epicenter. Multiply the damage from an ordinary volcano by thousands and you'll get a supervolcano eruption. Yellowstone is one of the largest volcanic systems in the world. It's erupted 3 times in the last 2.1 million years. The last time was 640,000 years ago. The ash covered an area comparable to about half of the United States. Fortunately, there were no people there, but nature got hurt. A similar eruption of a similar supervolcano occurred about 74,000 years ago. It was the Toba supervolcano in Indonesia that caused an apocalypse the human race barely managed to survive. According to some theories, only a few thousand people stayed alive at the time during the volcanic winter, but it's not confirmed. Since Yellowstone is a volcanic system located in a vast national park, it was important for scientists to find out exactly where the first spark would come from. They found out that Yellowstone's magma doesn't accumulate in one place, but hides in several separate underground reservoirs. The reservoir in the northeast of Yellowstone, next to a beautiful place called Sour Creek Dome, is the riskiest. Here, the red-hot magma comes into contact with the hot rocks of the mantle, which are located deep in the ground. Their high temperature keeps the magma in a liquid state. Imagine that you put a pot of hot milk on the stove. Nothing cools down, but only gets hotter, so the milk may soon begin to rise and flow out of the pan. The same thing is happening with the magma under Sour Creek Dome. Magma doesn't cool down there, and at some point it may start to come out. It'll be like a broken pipe from which a fountain of boiling water gushes. But how did scientists find out? The magma reservoirs are located at a depth of about 6 miles, and this whole area is incredibly hot. They used a special method called magnetotellurics. So, Earth's rotating core creates a magnetic field that surrounds our planet. Magma flows around the core, and it contains many magnetic minerals that also create magnetic fields. Scientists use special instruments that sense those fields emanating from the magma, like a metal detector senses lost jewelry on the beach. Using magnetotellurics, they scanned Yellowstone and discovered 4 large magma reservoirs. 3 of them emitted powerful electromagnetic waves, and in the 4th, which is in the northeast, they recorded a much stronger signal from the magnetic field. This is where the eruption is supposed to occur. But fortunately, it won't happen soon. Perhaps in tens of thousands of years, perhaps in hundreds. Phew, you can relax. No volcanic apocalypse is coming soon. But how do scientists know when this magma will start to erupt? Magma doesn't have a timer, and the volcano doesn't wake up with an alarm clock. So, magma flows inside the pores of solid rock. It resembles a dishwashing sponge with lots of small holes through which water passes. Magma penetrates these pores and fills them. For magma to start erupting outward, it must fill at least 40% of these pores. About 20% of them are filled now. But these hot rocks continue to heat the magma and keep it liquid, so it can flow between the pores. At some point, it will connect with other pools of the liquid magma and become a large stream that will rise to the top. How can we prevent this from happening? It seems that the solution here is to cool the balsam rocks, but it's impossible to do so. They are several miles deep, they are incandescent, and there are too many of them. And in any case, trying to cool a part of the Earth's core sounds like a very bad idea. All we can do is accept that nature has its own plans. If the eruption occurs in tens or hundreds of thousands of years, then perhaps humanity will find a way to solve this problem. If not, then we should prepare for the consequences. A huge global catastrophe starts with a massive, large-scale explosion. The erupting magma produces a gigantic amount of ash. A powerful burst of energy collapses the Earth's crust over the magma reservoir. This leads to the formation of a giant caldera. You've probably seen a huge crater in a volcano. So, this is the caldera. The natural disaster is so loud it deafens everyone who's nearby. The blast wave rises ash and pumice stone at a speed exceeding the speed of sound. Volcanic materials reach incredibly high altitudes in minutes. Then, this pillar of ash spreads and plunges a huge territory into darkness. The incandescent particles in the lower part fall under their own weight and heat the air around them. It's almost impossible to breathe. The red-hot pieces of pumice stone and ash set fire to the surroundings. All this hot mass turns into pyroclastic flows that destroy and burn everything in their path. Forests, houses, roads, everything turns into coal. No planes can fly there. Tiny particles can penetrate engines. Besides, it's impossible to see through such a dark gray, hot cloud. It's also dangerous to drive cars. Volcanic particles can burn tires. Luckily, thanks to seismic technologies, people have learned in advance about the eruption, so everybody has evacuated. The column of ash that has reached the edge of space continues to expand in different directions. The wind helps the volcanic dust expand. A giant umbrella-like cloud appears over the territory of Yellowstone. It's getting wider and wider and plunges a huge area into hot darkness. During the first 24 hours, ash falls on most of the United States and parts of Canada. It knocks out power lines, pollutes bodies of water, and destroys crops. Then, the rains begin. The water mixes with the ash and falls to the ground in the form of gray mud. And don't forget, it's also poisonous. The ash contains mercury, arsenic, and lead in large quantities. Such toxic masses poison rivers, lakes, land, and air. All this time, the volcano continues to erupt. The outbursts of magma, ash, and pumice can last for several weeks or even a month. And this is just the beginning. The ash soon begins to settle, but the sulfur dioxide released during the eruption spreads all over the atmosphere. This gas mixes with the atmospheric water vapor and forms an aerosol consisting of small particles. All this covers the planet like a veil. This cap makes it difficult for the sun's rays to pass through, which means it lowers the temperature of the Earth's surface. These events cause a sharp cooling of several degrees in the world. Farmers lose a huge amount of their crops. Food prices rise and economies collapse. There might be a famine all over the planet. Human civilization can plunge into chaos. In a few years, the temperature will start rising, but it will take at least a couple of decades to return to previous standards. What will become of humanity by that time? Of course, we will survive, but we'll have to rebuild our civilization. But don't be afraid. If nothing depends on us, let's just enjoy every day of life. Be grateful and help each other. Supporting and caring for each other even during the volcanic winter is a guarantee that humanity will survive.
So, you might have heard that Yellowstone National Park is sitting on top of a giant supervolcano. That's the reason why the area can boast powerful geysers and hot springs. But it also means that underneath Yellowstone, there is an enormous magma chamber. In 2015, researchers from the University of Utah found out that this chamber was much bigger than everyone had previously thought. They even found one more reservoir with magma under the top one. Apparently, the more spacious the chambers are, the more magma they contain. Together, the two reservoirs store a glob of magma that could easily fill the Grand Canyon not once, but 11 times. But you know the most worrying thing about the magma chambers? They tend to push against the ground above them. As a result, the land in Yellowstone rises about 1 to 2 inches a year. On top of that, Yellowstone has the status of an active volcano, and its volcanic explosivity index, yes, there is one, is 8 out of 8. Such a high number means that if this volcano erupted, it would be an apocalyptic event. To put it into perspective, the eruption of Pinatubo in the Philippines in 1991, which is considered the most powerful in living memory, was given a mere 6 on the volcanic explosivity index. Ha, loser. Now, let's figure out if there's anything to worry about. In March 2023, the University of Utah seismograph stations recorded 354 earthquakes in the entire region of Yellowstone National Park. Sounds like a lot. But keep in mind that the most impressive event of the month was a mini earthquake of magnitude 3.7. It was part of a swarm of 106 earthquakes that began on March 29th and continued until the end of the month. Yep, earthquakes apparently also come in swarms, so be aware. Experts say that Yellowstone's seismic activity is, well, kind of more active than usual, but it's really nothing serious. A geophysicist working at Yellowstone Volcano Observatory called Michael Pollan claims that the volcano won't erupt anytime soon. For this to happen, there must be enough magma ready to erupt beneath the surface. Whew. There should also be enough pressure to cause this magma to rise. But neither of these conditions exist today. According to the expert, Yellowstone is stable now. At the same time, Pollan and his team are keeping track of all kinds of underground activity, looking for warning signs of possible eruptions. Some of them can be the frequency of earthquakes and ground deformation. Thousands of mini earthquakes, coupled with extreme changes in the surface of the ground in that area, can be alarming. The team also monitors the temperature of the park's thermal features. That's another noteworthy sign of a potential disaster. Park-wide changes in geyser activity, as well as gas and thermal emissions. So, despite the media claims that Yellowstone is due to erupt soon because the last eruption happened 70,000 years ago, that's not how volcanoes work. Experts say that it's one of the most popular misconceptions about volcanoes. They don't follow timelines. If a supereruption did happen, though, the most worrying thing for us would not be the lava flows, and not an earthquake that would most likely accompany the natural disaster. No, the worst consequence of such a supereruption would be ash and ashfall. Let's have a look at what it was like when the Yellowstone volcano erupted many years ago. There have been at least 3 supereruptions in the history of the volcano. The most powerful of them was 2,500 times more devastating than the terrifying eruption of Mount St. Helens in Washington state in 1980. As for the most recent supereruption, it was dubbed the Lava Creek eruption. It formed the Yellowstone caldera after spewing out an insane amount of dust, volcanic ash, and rock into the air. Recently, scientists have also learned about 2 other previously unknown supereruptions that happened around 9 and 8.7 million years ago. The younger of the 2 is now considered to be the largest recorded event of the whole Snake River Yellowstone volcanic province. Anyway, let's have a look at what was going on all those millions of years ago. Because I wasn't around then, so we're all assuming this stuff based on evidence. The first signs of the disaster appeared long before the catastrophe broke out. For thousands of years, the heat had been welling up from within the planet's insides. It had been melting rock beneath the planet's crust and leaving behind huge chambers. They were filled with a pressurized mixture of semi-solid rock, magma, water vapor, and different gases, including carbon dioxide. All this scorching underground soup was expanding since more and more magma arrived with time. The land over the volcanic system was rising upward almost unnoticeably. A year before the supereruption, Yellowstone gave a warning, a burp maybe, but that long ago there was no one who could interpret these signals. Plus, those alarming processes were mostly going on underground. For example, decompression releases gas bubbles. While bursting, such bubbles can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging in that area. Not long before the eruption started, the growing pressure pushed the ground over the magma chamber up. This created a dome-shaped uplift. Narrow cracks started to open along the edges of this dome. Imagine opening a bottle of soda after you've shaken it. Something like that was happening near the volcano. Think Mentos and Diet Coke. The pressure was released through the fractures when gases were bursting out from under the surface. So right before the disaster, the ground around the Yellowstone volcano lifted. Geothermal pools and geysers heated up to boiling temperatures and got more acidic than usual. The magma started to rise toward the surface. At one point, the rock roof of the magma chamber couldn't resist anymore and the eruption kicked off. Small but constant tremors began to move the ground days before the catastrophe. But the real shaking didn't start until several minutes before the eruption. With a deafening roar, a massive column of lava and ash hurled up into the air. Within several minutes, a pyroclastic flow rushed across the area at a hurricane-force speed. Such a flow is a liquid mixture of half-solid lava pieces, volcanic ash, and hot expanding gases. It looked like an extremely hot toxic snow avalanche. With a temperature of about 1300 degrees, it was burning everything in its path. The volcano kept pumping ash for days on end. For all living creatures, ash fallout was one of the most dangerous consequences of the eruption. Volcanic ash turns into glassy cement within seconds of being inhaled. Most animals didn't have a chance to survive. Even thick trees started to collapse under the weight of this dense substance. It only took a couple of days until a thick layer of ash covered huge territories. After the ash got into the stratosphere, the temperatures all over the world started to drop. The eruption was rich in sulfur, which is an effective sunblocker. That's why it soon got so cold that there was no summer in the whole world for the next several years. Animals couldn't find food and clean water. This natural disaster, called the Gray's Landing supereruption, was colossal. That's how researchers described it in their recent studies. It affected a huge territory. The streams of lava enameled an area as large as New Jersey in scorching hot volcanic glass. It instantly sterilized the land surface, wiping out all the plant life that had been thriving there before. Now, if such an eruption were to happen these days, it would cover Colorado, Utah, and Wyoming with almost 3 feet of toxic volcanic ash. Many regions would be plunged into darkness. Even the coast, where most Americans live, would experience problems with the spread of the ash cloud. It would destroy crops and contaminate pastures, ruin power lines and electrical transformers. Well, so I'm sure you'll agree with me, it's a good thing that such a disaster isn't expected to occur anytime soon. Hey, we got enough other stuff on our plate. So, you notice anything weird? Recently, there have been alarming changes in the water levels in different parts of Yellowstone Lake. At the same moment, the water level can be rising on one side of the lake and falling on the other. Ooh, it looks as if the lake basin gets lifted by some underground forces. Can it be a sign of a looming disaster? Geysers, mud ponds, and hot springs turn Yellowstone National Park into some extraterrestrial world. And all these wonders are fueled by a mighty supervolcano. Supervolcanoes produce super eruptions. When it happens, they launch more than 240 cubic miles of ash, molten rock, and hot gases up into the air. To make it easier to imagine, 4 super eruptions could fill the Grand Canyon to the brim. The Yellowstone giant was thought to be responsible for at least 3 enormous eruptions and countless smaller ones. In that region, the volcanic deposits are scattered over tens of thousands of miles. Scientists believe they had been created by many weak eruptions. But after doing more research, experts found out these deposits had been left by 2 previously unknown super eruptions. Those probably took place about 9 and 8.7 million years ago. This discovery means that the area around the Yellowstone volcano used to face a super eruption every 500,000 years. But over the last 3 million years, the hotspot has seen only 2 super eruptions. It makes scientists believe these catastrophic events are slowing down, or just maybe one is overdue. Anyway, if the Yellowstone supervolcano went off with as much power as it had 2.1 million years ago, it would spit out more than 588 cubic miles of boiling lava. That's more than 4,500 times the volume of Sydney Harbor. That's a lot of lava. Whether it's likely to happen or not is another question. There's no doubt that something is going on with the volcano. The water level changes in Yellowstone Lake mean the caldera is lifting under the surface. And the caldera is what's left over after a volcano erupts and then collapses. The Yellowstone caldera is not just going up, creating a dome-shaped uplift. It also moves up and down in a kind of breathing motion. It might be because the magma is seeping into the crust, or because this magma is heating up the Yellowstone hydrothermal system, making it expand and raise the crust. Yellowstone has the status of an active volcano. Its volcanic explosivity index is 8 out of 10. Such a high number means that if this volcano erupted, it would be an apocalyptic event. Right before the disaster, the ground around the national park would lift. Geothermal pools and geysers would heat up to boiling temperatures and get more acidic than usual. The magma would start to rise toward the surface. At some point, the rock roof of the magma chamber wouldn't be able to resist anymore, and the explosion would kick off. A massive column of lava and ash would shoot up to a height of over 16 miles. After that, the volcano would keep pumping ash for days on end. The mixture of lava, ash, and gas would be hotter than 1,800 degrees Fahrenheit. It would travel through the area at a speed of 300 miles per hour, faster than a racing car. The air near the center of the eruption would heat up to 570 degrees Fahrenheit. One of the most dangerous consequences would be ash fallout. Volcanic ash can turn into glassy cement within seconds after being inhaled and getting in the lungs. People and animals would have problems with breathing. Okay, so that's an understatement, just so you know. Buildings would start to collapse under the weight of this dense substance. It would take just several days until a 10-foot layer of ash covered the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures all over the world would start to drop. If the eruption was rich in sulfur, an effective sunblocker, it would get so cold there would be no summer in the entire world for the next several years. The monsoon seasons would change. Agriculture would face serious problems. There would be issues with food supplies. Over the past 50 years, the Yellowstone caldera has risen almost 2 feet. It shouldn't alarm you, though. Experts are sure it's a natural behavior for Yellowstone. Periods of dome-shaped uplift are followed by the caldera lowering. Scientists think the supervolcano doesn't present any danger at the moment. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. The probability of the eruption is 1 in 730,000. Safe to say, it's a long shot. Even better, a recent study made the researchers believe the hotspot might be in a state of decline right now, even despite all the breathing and dome-raising activity. Still, there have been tons of discussions about what people could do to prevent the disastrous supereruption from happening. And the most popular and seemingly effective idea was to cool the Yellowstone supervolcano down. Unfortunately, there's a catch. The volcano leaks out only 70% of the heat which comes from its magma-filled chambers, but the rest of the heat stays inside. As soon as it reaches a particular threshold, the volcano erupts. If it was possible to extract at least 35% of the Yellowstone volcano's heat, the eruption could be avoided. The cooler the magma is, the thicker and stickier it gets. It stops being so fluid and doesn't try to get out to the surface anymore. After considering these facts, NASA scientists came up with a plan. They suggested drilling a 6 miles deep well and pumping down cold, pressurized water. The temperature of the water that would get back to the surface would be approximately 662 degrees Fahrenheit. This way, the heat would be gradually extracted from the volcano. And if a geothermal plant was built on the site, it would generate plenty of electric power. It would be very simple to produce, and its price would be very alluring, about 10 cents per kilowatt hour. At first glance, it was an amazing idea. But sometime later, it started to receive a lot of criticism. Imagine drilling through the Earth's crust, getting deeper and deeper, and then wham bam, you hit a hypothermal pocket. Uh-oh, get ready for a catastrophe. This can release gases that are likely to cause a series of super powerful explosions. In the worst-case scenario, it may even trigger a full-scale volcanic eruption. Now, you already know about its catastrophic outcomes, from fountains of lava and avalanches of molten rocks to climate changes all over the globe. Yeah, not good. Or let's say you're drilling a well to deliver cold water to the volcano, and then you suddenly hit its magma chamber. In this case, instead of cooling the giant down, you'll make the top of the magma chamber much more fragile than it used to be, and the whole construction will be at risk of collapsing at any moment. And don't forget that your drilling may also release toxic gases. They often accumulate at the top of the reservoir with magma. Can it get any worse? Well, yes it can. The whole process would stretch for more than 16,000 years. This method is too risky to cool the volcano down as fast as people would probably want. And scientists aren't even 100% sure that when the cooling system construction is finished, the volcano will stay cold for at least another 100 years. And last but not least, the project of making the Yellowstone supervolcano a bit cooler would cost a mind-boggling $3.5 billion. A huge price for something that might not work out altogether. Oh, by the way, Yellowstone isn't the only volcano that has a lava dome that's lifting at the moment. Lava domes are created when magma gets to the surface and then gathers around the vent. Scientists have found one of those inside an underwater volcano in Japan. This dome is more than 2,000 feet high and more than 6 miles wide. Even though the Japanese supervolcano seems to be sleeping, experts don't let their guard down. A volcanic system can go from being calm and docile to teetering on the edge of an eruption in the blink of an eye. Another massive dome is growing in the central Andes, on top of the planet's largest active magma store. The Altiplano Puna Plateau, well there's a tongue twister, and where the dome was found, is the second highest plateau in the world, and the dome itself is more than half a mile tall. You might wonder how come experts have known nothing about this enormous uplift until recently. The answer is simple. It was hidden within the plateau. It's an arid region littered with volcanoes, and it stretches for thousands of miles. Yep, another case of hiding in plain sight.
It happened around 8.7 million years ago. All of a sudden, vast grasslands started to open. Clouds of volcanic gas and ash covered the sky. Flows of lava streamed down the hills and across the plains. Within minutes, black volcanic glass started to rain from above, wiping out animals, crushing plants. It didn't take long before the land caved in, opening giant pits filled with red-hot magma. It was the greatest eruption of the Yellowstone supervolcano. This giant, which is actually one of the largest active volcanic systems on the planet, wasn't named Supervolcano for nothing. Spreading deep underground and extending for hundreds of miles, supervolcanoes are complicated structures. Experts are still unsure what processes can trigger these fire-breathing monsters and lead to super eruptions. When it happens, more than 240 cubic miles of ash, molten rock, and hot gases get hurled up into the air. 4 super eruptions would be enough to fill the Grand Canyon to the brim. Volcanoes create mountains, but supervolcanoes wipe them off the face of the earth. They change climates and ecosystems. Thankfully, these disastrous events don't happen more often than every 50,000 years or so. Supervolcanoes appear when huge volumes of magma are trying to escape from deep underground and burst through the Earth's surface. Usually, all this magma gets stuck, unable to break through the planet's crust. Large pools of pressurized bubbling magma gather at a depth of several miles. The pressure keeps growing since more and more magma is trying to get to the surface. And then, wham, bam, a super eruption goes off. All those millions of years ago, the first signs of the disaster appeared long before the catastrophe broke out. For thousands of years, the heat had been welling up from within the planet's insides. It had been melting rock beneath the planet's crust, leaving behind huge chambers.
Those were filled with a pressurized mixture of semi-solid rock, magma, water vapor, and different gases, including carbon dioxide. All this scorching underground soup was expanding after more and more magma arrived with time. The land over the volcanic system was inching upward, slowly, almost unnoticeably. A year before the super eruption, Yellowstone gave a warning. But that long ago, there was no one who could interpret these signals. Plus, those alarming processes were mostly going on underground. For example, decompression released gas bubbles. While bursting, such bubbles can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging that area. Not long before the eruption started, the growing pressure pushed the ground over the magma chamber up. This created a dome-shaped uplift. Narrow cracks started to open along the edges of this dome. Imagine opening a bottle with soda after you've shaken it. Something like that was happening near the volcano. The pressure was released through the fractures when gases were bursting out from under the surface. Right before the disaster, the ground around the Yellowstone volcano lifted. Geothermal pools and geysers heated up to boiling temperatures and got more acidic than usual. The magma started to rise toward the surface. At one point, the rock roof of the magma chamber couldn't resist anymore, and the eruption kicked off. Small but constant tremors began to move the ground days before the catastrophe. But the real shaking didn't start until several minutes before the eruption. With a deafening roar, a massive column of lava and ash hurtled up into the air to a height of over 16 miles. Within several minutes, a pyroclastic flow rushed across the area at a phenomenal hurricane-force speed. Such a flow is a liquid mixture of half-solid lava pieces, volcanic ash, and hot, expanding gases. It looked like an extremely hot, toxic snow avalanche. With the temperature of more than 1,300 degrees Fahrenheit, it was burning everything in its path. The volcano kept pumping ash for days on end. The air in that area heated up to 570 degrees Fahrenheit. For all living creatures, ash fallout was one of the most dangerous consequences of the eruption. Volcanic ash turns into glassy cement within seconds after being inhaled and getting in the lungs. Most animals didn't have a chance to survive. Even thick trees started to collapse under the weight of this dense substance. It only took a couple of days until a 10-feet layer of ash covered the territory of about 50 miles around the center of the eruption. In the end, tiny particles of volcanic ash coated almost all the western part of North America. After the ash got into the stratosphere, the temperatures all over the world started to drop. The eruption was rich in sulfur, which is an effective sun blocker. That's why it soon got so cold that there was no summer in the whole world for the next several years. The monsoon seasons changed. Animals couldn't find food and clean water. This natural disaster, called the Gray's Landing supereruption, was colossal. That's how researchers described it in their recent studies. It covered more than 8,900 square miles of what's now southern Idaho and northern Nevada. The streams of lava enameled an area as large as New Jersey in scorching hot volcanic glass. It instantly sterilized the land surface, wiping out all the plant life that had been thriving there before. There have been at least 3 other supereruptions in the history of the Yellowstone volcano. They happened 2.1 million, 1.3 million, and 64,000 years ago. They were 6,000, 700, and 2,500 times more powerful than the devastating eruption of Mount St. Helens in Washington state in 1980. The most recent supereruption was dubbed the Lava Creek Eruption. It formed the Yellowstone caldera after spewing out 240 cubic miles of rock, dust, and volcanic ash. These days, Yellowstone National Park is a mind-boggling collection of 10,000 mud pots, hot springs, geysers, and vents emitting volcanic gases. Heat-loving microorganisms live in most of them. They paint the park in its brilliant colors. The most famous geyser is called Old Faithful. It got this name at the end of the 19th century because of how regular its eruptions were. This geyser is more active than others, erupting about 17 times a day. Each of these magnificent events lasts from 1 to 5 minutes, and the fountain of steaming water can reach the height of 180 feet. Scientists have spent many years trying to figure out what's hiding under Yellowstone Park. They've discovered that surface water goes several miles down into the crust. It gets heated and boils, supplying the geysers. Around 7 miles below the surface, there's a reservoir of half-melted rock. That's the magma chamber, and it's more than 30 miles wide. An enormous plume of hot rock, which looks somewhat like a mushroom, feeds this chamber. It rises from the depth of 400 miles, traveling through the planet's upper mantle, a thick layer of mostly solid rock. Sometimes, this plume overheats the magma chamber. The land in that place lifts, and tiny earthquakes help some liquid escape to the surface. The pressure inside the chamber drops, and the ground lowers again. Since 2004, some parts of the Yellowstone caldera, which is a clever word for a volcanic crater, have been surging upward much faster than usual. The rate's been almost 3 inches per year. No uplift has been that quick since scientists started close observations in the 1970s. And still, experts are sure the supervolcano doesn't present any danger these days. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. Even if there's some volcanic activity, it's more likely to be a spurt of oozing molten rock known as a lava flow. It does present some danger, but it's easily avoidable. Or it can be a hydrothermal explosion. Then, a large volume of superheated water trapped below the surface will rapidly turn from liquid into steam. This steam, along with boiling water, mud, and pieces of rock, will burst through the surface with great force. Then, the debris will litter the area of up to several miles in diameter.